So hello dear students, today we will solve some other numerical problems based on gravitation chapter. Two problems I have written already on the board here. So let us solve one by one. This is mostly related to, not mostly, it is absolutely related to your competitive questions only. So just we have to understand the question and how much it is necessary to follow it in such a way that we will get a correct answer. Means expected answer what is given in the problem, that is task here. So what is here? What is the depth at which the value of acceleration due to gravity becomes 1 by n times of the acceleration due to gravity on the surface of the earth. So r is given here, radius of the earth. So what is, with the diagram let us move here. Acceleration due to gravity on the surface of the earth is g. So as we move here, gm by r square here on the surface of the earth. So how much depth inside? So how much depth? So inside how much depth is there? So what is above? So if it is like this here, so depth it is there inside the earth. So inside the earth, right? So let us call this is the radius of earth here. Inside the depth is equal to how much? It will be equal to, that is 1 by n times here. So 1 by n times of acceleration due to gravity on the earth. So let us check here. Acceleration due to gravity, that is equal to g of 1 minus v by r. So where r is radius of the earth here, right? So as it is given here, this part acceleration due to gravity inside the earth or the depth here, it is 1 by n. So I will write it here like this. Then what will happen? 1 minus v by r here, right? So g will get cancelled, remains with 1 by n. So 1 minus v by r here. So we can write it here as equivalent to 1 by n. So I will write it here. So 1 by n, that is equal to r minus d by r here. So let us go ahead with the cross multiplication. R is equal to n of r minus d here. So r is equal to n r minus n d here. So n d is equal to n r minus r here. So what will happen? D is equal to n of n minus 1 of r here. So that is of again n. So n d is equal to n r minus r will come here. So d directly I have written. So n minus 1, r I have taken outside, n minus 1 divided by n. So this is the expected depth where it is equivalent to the acceleration due to gravity on the surface of the earth, that is equal to the acceleration due to gravity on inside the depth here. So how much it is? D is n minus 1 of r by n here. So let us move on to the second problem here. Let us move on to the second problem here. What is that? The value of acceleration due to gravity at a height x is equal to 10 km from the surface of the earth, x here. At what depth inside the earth is the value of acceleration due to gravity has the value of x here. So let us bring the diagram first. So what is the diagram here? So if it is, this is the earth here, right? So for radius r, right? How much height? Height is what here? How much height is there here? Height is given as a 10 kilometer. So that acceleration due to gravity on the surface of the certain height above. So that will be equivalent to the certain height inside. So certain height inside depth. So how it will be equal to? So g. So we have acceleration due to gravity at a certain height, that is equal to g of r square, right, divided by r plus h whole square. So we can write it this acceleration due to gravity at a certain height from the surface of the earth. We can also write it here g of 1 plus h by r whole raised to minus 2. So here we can also frame that in such a way that, so 1 minus 2h by r it is, right? So this is of what? Acceleration due to gravity at a certain height. So I will write it here 1 minus 2h by r here. So let me call it as this is equation 1. Then what about acceleration due to gravity at a happen here? So what it will happen here? GH is equal to GD. So what is GH? We will take the equation 1 here. So that is of G of 1 minus 2H by R. So that is of G of 1 minus D by R. This is of height, certain height from the surface of the earth, and GD is a certain inside the surface of the earth here. So both the G and G will get cancels. Remains with the 2H by R here. That is equal to 1 minus D by R. So here R1 will also get cancels each other. Now R is equal to minus D by R. So minus sign also get cancels here. Remains with the 2H by R. That is equal to D by R here. So what it will happen here? R and R will also get cancels. Remains with 2H is equal to D where H is given as a 10 kilometer. So what is happening here? 2 into 10 kilometer. So what happens? 20 kilometer. Where the depth. So depth is what about? This is of 10 kilometer. Where acceleration due to gravity at the depth is equal to acceleration due to gravity at a certain height. So this is the value of x on both the on certain height of inside it is, right? So that is equal to x of surface, certain height it is. So height. So we can also say it is a depth also. So this is the solution where D is equal to 20 kilometer. So D is equal to 20 kilometer here. So let us solve the another numerical problem. Other two problems here. So next problem, what is given here? Acceleration due to gravity G on the surface of the earth. The value of acceleration due to gravity at a height 32 kilometer above the earth's surface is what? Acceleration due to gravity G on the surface of the earth. The value of acceleration due to gravity at a height 32 kilometer above the earth's surface is what? That is the task is given here. So already given the radius of the earth is nothing but the 6,400 kilometers. Let us move on to the diagram here. So what is here? Radius already given, that is R is equal to 6,400 kilometer it is. Yes. So about means about certain height. So here what is the acceleration due to gravity here? So at a certain height here. So this is not a height. This is the certain height. This is the radius it is given. So let us move on to the solution here. What is we have acceleration due to at a certain height. We can write it here G of R square divided by R plus H whole square. So we can bring here G R plus H whole square. We can write it here like this also. Now we have 32 kilometer here. We can also write it here G of 1 plus H by R whole square. We have here GH is equal to GR divided by R plus H whole square. We can also write it in this form here. G 1 plus H by R raised to minus 2. That also can be written as G of 1 minus 2H by R here. So this is due to the small arrangement in the formula. That is acceleration due to gravity, a certain height from the surface of the earth here. So directly I will take this form here. So what it will happen? GH is equal to, H is already given here. What is that? H is 32 kilometer, right? So R is also given, radius of the earth 6,400 kilometer here. So only thing that we have to substitute the H and R value in this form, and then what we will get the acceleration due to gravity R in this formula here. So let us go ahead with the direct form. So I will write once again G of 1 plus 2H by R, right? So GH. So 1 minus 2 into 32 here. So 6,400. So what do you get here? G of 1 minus 64 into divided by 6,400. we can write it here. So what do we get? 100 minus 1 divided by 100 here, right? So G of 99 by 100 here. So we can write it here, 0.91 is equal to here. So acceleration due to gravity above the surface of the earth, that is equal to the 0.99 acceleration due to gravity on the surface of the earth. So let us move on to the once again revision of the how we did the solution for this question. Acceleration due to gravity G on the surface of the earth. So value of acceleration due to gravity at the height 32 kilometer. So how much? Above the surface of the earth. So radius of the earth is already given here. That is what? So this value R is already given. Then certain height H, that is also given here. So only thing that we have to substitute these values in the expected question. So means expected answer, what we get, the acceleration due to gravity from the certain height above the surface of the earth, that is the G of 1 minus 2h by r. So we can frame this by the help of GH is equal to G of r square divided by r plus h. So we can write directly, we can write it in the form of G of 1 minus h by r raised to minus 2 here. So we can write. So it becomes as a G of 1 minus 2h by r. So directly I have substituted this in the form of solution of this equation here. So we'll get the value here, how much? Substituting h and r value we will get here 0.99 g here. That is acceleration due to gravity above the certain height from the surface of the earth, that is equal to 0.99 acceleration due to gravity on the surface of the earth here. So this is about the solution of that question. Right? Now we'll move on to the next problem, that is height of the point vertically above the surface of the earth at which the acceleration due to gravity becomes 1% of its value at the surface is r is equal to radius of the earth here. Now what is happening here? If you consider this is the earth having the radius r here, then certain height that is of 1%. So that is of 1% which is revolving around here. Means what will be the height above the acceleration due to gravity here. So height is already given 1% here. So GH is equal to GS of 1% here. Right? Now what it will give? GH solution. Right? Solution of this problem. GH is equal to, directly we can take G is equal to r square divided by r plus h whole square here. Right? So as 1%, we will write it as 1 by 100 here. Right? Now that is 1 divided by 100 is equal to G of r square divided by r plus h whole square here. Now what it will have is r square by r plus h whole square. So we can write it here G of r by r plus h whole square. Directly we can write it here. So here GH we can also write it as G by 100. By means GH is equal to 1 by 100 of gravitational on the surface of earth here. So that is equal to G of r divided by r plus h whole square. Right? So G will get cancels. Here 1 by 100, that is equal to r by r plus h whole square unit. Right? Now what will be the next step here? So 1 divided by 100, that is equal to r plus h whole square. Right? So I will take the root here. So 1 by 100. So that is equal to r by r plus h. Now what it will happen? 1% of its value at the surface, that is equal to height is 9 r. It is 9 times of radius of the earth here. The next problem is, if the radius of the earth is r, then the height h at which of the acceleration due to gravity g becomes 1/4 is. Now the simple is, this is the earth of a radius r is there here, right? Then the height at which the acceleration due to gravity g is 1/4. So gh is equal to 1/4 is. So where it is, that's only we are going to find out here. As we know, acceleration due to gravity on surface of earth. Is g is equal to gm by r. This we know already. So that is nothing but the gr square is equal to gm here. Now at a certain height, it is given by 1/4 of g. Now we have acceleration due to gravity at a certain height. We have formula directly. What is that? That is nothing but the g of r square divided by r plus h whole square. So we can also write it here, g r plus h whole square, right? Now we have gh is equal to g of r plus h whole square. So we can also write it here, gr square r plus h whole square, right? Now this part is 1/4 of g. So both the sides g will get cancels, remains with 1/4, that is of r square divided by r plus h whole square here, right? Now we'll have cross here, r plus h whole square, that is of 4r square. Now take the square outside. What it will have is r plus h remains here, 2r, right? Now h is equal to 2r minus r. So that is equal to what? H of r. That means radius of the earth, that is equivalent to the certain height. Right? When it is equivalent, then only it will becomes 1/4 of acceleration due to gravity at the height as the acceleration due to gravity on the surface of the earth here. On to the next problem here. R and small r are the radii of the earth and the moon respectively. Rho e and rho m is the density of earth and moon respectively. The ratio of acceleration due to gravity on the surface of the earth and the moon here. So let us move on to the diagram here. We'll just take a solution of radius of the moon and r and b the density of the moon. So what we need to find out here, the ratio of acceleration due to gravity on the surface of the earth, and the surface of the moon here. So we need to find out here ratio of Eg by Em here. So or else we can take it as E, small e here, right? So acceleration due to gravity on the earth by the acceleration due to gravity on the moon here. Before going to that, we should check here, as we know acceleration due to gravity. So acceleration due to gravity on surface of earth. So on the surface of the earth here, surface of earth. So as we know here, G is equal to Gm by R square here, right? So as it is, Gr square is equal to Gm. That we know very well, right? What is rho here? Rho is what? 4/3 pi r cube. Rho is nothing but the density here, where m will give you cube 4 by 3 pi r cube of rho here. So this is of mass, means mass of the body or a mass of the earth here. As we counted here mass of the earth here, so mass of the earth. So what it will be? 4 by 3 pi r e cube r e it is. So this is, let us call this is a 1 here. Then what about the moon here? Moon is m, mass of the moon here. 4 by 3 pi r m cube r m it is. Right? As we know here, gm, that is what? Earth it is. So E by r e square it is. So this is for earth it is. Acceleration due to gravity on surface of earth here. As we hear, acceleration due to gravity on moon. So gm, m small m by rm square. This is for moon. Right? Now in place of mm, means mass of the moon, mass of the earth, we have to substitute here. What will get? Mass of the earth. So capital G, m is a 4 by 3 pi r e cube rho e it is. Then what about m here? Acceleration due to gravity on the mass, that is capital G 4 by 3 pi r m cube rho m it is. Now move on to the ratio of it. Ratio of acceleration due to gravity on the surface of the earth and acceleration due to gravity on the surface of the moon here. So we have capital M means capital G 4 by 3 pi r e cube rho e here. Then divided by capital G 4 by 3 pi r m cube rho m. So G will get cancels, 4 by 3 will get cancels, 5 will get cancels, remains with RE. So here RE cube rho E divided by RE square. Here we have forgotten to write RE square. So RM square due to this form. So this part we have negated here. So what it is happened here? RE square. So RM square. This and this one will get cancelled. This and this one will get cancelled. So remains with. So directly we write it here. Remains with RE, right? So RM of rho E here. So finally we got the conclusion here. Acceleration due to gravity on surface of earth and acceleration due to gravity on surface of moon. Ratio of it, that is equal to RE of rho E divided by RM of rho M. So this is the expected answer which is given as a task to solve the problem here. So what is that? We need to find out the acceleration due to gravity on the surface of earth and the moon it is. If the mass of the earth is 80 times of that of the planet, then the diameter of double of that of the planet and G is on the earth. Acceleration due to gravity on the earth is 9.8 meter per second square. The value of G on the planet. So as we know here, acceleration due to gravity. Acceleration due to gravity on earth surface. So earth surface. So acceleration due to gravity on earth surface G is equal to Gm by r square here. So similarly, earth is, right? So similarly we have a planet here. So this is a planet, right? So its acceleration due to gravity of a planet. So that we have to going to find out here. So what is that? Acceleration due to gravity Gm by r square. So already it is given mass is equal to m by 80, right? Then as well as radius is equal to 1 by double that of the planet. So what is that? 2 it we are going to find out the acceleration due to gravity on planet here. So Gm by r square. So we'll put the mass of this and we'll put the radius as this here. So what we get? Gm by 80, right? So that is divided by again r divided by 2 whole square. So what we get? Simultaneously Gm by 80 of r square by 4 it is. So we'll get it here G, right? So 4 ones are 4 twos are. So that is of 20 by r square here, right? So just look at this part. This is nothing but the Gm by r square. That is acceleration due to gravity on the surface of the earth here. So what we get here as acceleration due to planet is nothing but the Gm by r. That I will write it here G divided by 20 here. So this value G on surface of the earth is already given, it is 9.8 meter per second square. So we need to put the value here. So J on planet, that is equal to 9.8 divided by 20 here. That is almost 0.49 meter per second. This is the acceleration due to gravity on planet here. This is the expected answer. So what is given here? If the mass of the earth is 80 times that of the planet. So 80 times that of the planet means that is nothing but the planet P here. So that is of planet P radius. Double the diameter of that of the planet. Then the acceleration due to gravity on the surface is a 9.8 meter per second square. Then the value of G on the planet. So as we know here, acceleration due to gravity on the surface of the earth is G is equal to Gm by r square, where G is a gravitational constant, M is the mass of the earth, and r square is nothing but the radius of the earth. So same concept it is applied for the planet here. So planet we have a mass of planet here, right? And we have a radius of planet. Sorry. Then radius and the mass of the planet is given as mass of the planet is equal to, mass of the earth is equal to, that is 1 by 80 times, or else you can say the 80 times of earth. So like that, radius of planet, that is equal to double of the earth here. So it is written in the form of here. As we know the acceleration due to gravity on the surface of the earth, this form we can frame for earth as well as the frame for planet. So Gme by Rb square. So this is the mass of the earth and radius of the earth here. Then substitute here on the planet here. So Gnp and Rb square. Instead of writing Mp and Rb, directly I have written here, that is the G is equal to 1 M by 80 here and R by 2 whole square. Then what it will happen? Gm 80 of R square by 4 because square it is. So it will get cancels each other and just account Gm by R square, that is nothing but the G here. What is G? G is the acceleration due to gravity on surface of earth it is. On the surface of earth it is. Right? This value already given here 9.8 meter per second square. Just put it here, you will get the value of acceleration due to gravity of a planet, that is 0.49 meter per second square here. So that the acceleration due to gravity on the surface of the moon is 0.2 times the acceleration due to gravity on the surface of the earth. If Re is the maximum range of the projectile on the earth's surface, what is the maximum range on the moon's surface? The same velocity of the projectile here. So as we know here, the projectile. So projectile, you know the idea about it. That is launching here. That is projectile. So 1 over the tangential over the acceleration. Here it is given acceleration due to gravity on the surface of the moon it is. So that is 0.2 times of the acceleration due to gravity on the surface of the earth. So Re is the range of it. That is maximum range of projectile on the surface of the earth. So when we kept one projectile here on the surface of the earth, that is about maximum range it is. So what is that projectile here? R. So R is equal to U square sin 2 theta by G here. Right? Where projectile, what it will happen? dr by d theta it is. That is of what? G square by u square by g is equal to cos 2 theta by 2 here, where 2 theta is equal to 90 degree, where theta is equal to 45 degrees. Now differentiating dr by d theta is equal to 0, which differentiation of dr by d theta is equal to 0, then r maximum. So r maximum we will get it as u square by g is equal to sin 2 theta, right? So as u square sin 2 of 45 degree, that is of 90 degree here. So g here u square by g sin 45 degree is equal to sin 90. So sin 90 degree is equal to 1 here. So that is r maximum will be u square by g here, right? So similar. So as Rm divided by Re, that is equal to, here both will get cancels, it will come up. So Ge by Gm here. As we know, it is given in the question, Gm is equal to 0.2 of Ge here. So Rm maximum range of Re, the ratio it is equal to Ge by 0.2 Ge here. So both will get cancels. So Rm is equal to 1 by 0.2 is a phi of Re. So that is what the maximum range of the projectile on moon, that is equal to 5 times of maximum range of the earth here. So that is the solution of the given question.